Well, hello and welcome. It is time once again to try to fix something. And today on the workbench, another dead PS5. Yeah, that's what I work on. So, it looks beautiful. It's supposed to be totally dead. I mean, it does really look nice. It's supposed to be totally dead though, and yes, can confirm no power whatsoever. So let's get right into it. Let's just see if it's been messed with before. All right, side plate is off. And yes, the security tape has been removed. But the majority of the screws are there, so that's something. But yeah, I'm going to say she's been opened up before. Let's see how bad it could be. Alright, well, with that plate, that cover removed, we're getting down to the metal. And still looking pretty clean. No roaches, at least. No signs so far of previous work, like ripped cables or anything. Now it's time to take off all these screws. And, well, I could check now that I think of it. Let's just check, see if we have 12 volts. Sometimes I forget to do that. Let's just see if we have 12 volts. On this 4-pin connector. Nothing there. Well, no, hang on. Let's do this. I had unplugged it, preparing to take it on apart. Nothing on that one. Oh, nothing on that one. So no 12 volts. Okay. Interesting. How about, is there a short? Let's see, if I short the ground, you get about 3 ohms. Is there a short there? Meg ohms. How about a short there? No. So it doesn't look like we have a shorted 12 volt rail. So maybe just a dead supply this time. Maybe. Let me see if I can get down to that supply. I do have a spare one. I'll see if I can get that supply out, and we'll test it, out of the chassis. Well, as I go to remove these screws out of the back of the chassis here to take the whole assembly out, those screws are missing. So, yeah, somebody's already done this. Interesting. All right, well, I got the chassis out of the frame here. I've got power into that supply, and I'm getting nothing out. Absolutely nothing. Which brings up the possibility that I have a dead supply and a dead board. The eBay combo special. Let me get another supply. I know I have a spare supply. This is a 1015, I believe, so I should have some of these supplies. This should be a 400 DR or ER. Let me find a spare one. We'll throw it in there, and I'll bet you that board doesn't work. Well, I have installed one of my spare supplies, and I can confirm now that we do have 12 volts right there. So we have a good supply. I don't have the fan installed, but I just want to see if we get a light or, I'm guessing we're going to have a beep on off. Just a guess. Let's see what happens. No. No beep whatsoever. Well, it's not going to beep for the jet because there's no drive in it. But it should beep for power. Cables connected and everything. Yeah. I don't think anything is wrong with that LED cable, but I'll pull it out. No. Okay, so a totally dead board and a totally dead power supply. What are the odds? Well, let's get on down to this PCB and we'll get it inside and see if we can figure out why it has no power. Alright, well, I got the PCB out and I was just taking a quick look at it, and I think we can see kind of what's going on around here. Somebody has tried to replace the south bridge or reflow it or drowned it in flux. I don't know. So, yeah, that's why we're dead. Okay. Let's get it inside and see how bad it looks. Alright, well, here we are inside the workbench. And let's just take a, let's just go straight to take a look around the south bridge under the microscope if we could. I think that's what's going to be the most interesting. I see a solder ball sticking out the left side there. Let's look at a side profile of this south bridge. Not sure how well that's showing up, but some of those solder balls look, you know, rather small and like not making contact with the board. Like that fourth one from the left there. So, and look at that one there. That far right one looks tiny. Almost like this south bridge was pulled from another one and not reballed. It was just pulled and transferred over. I don't know. But that solder ball coming out the edge there kind of makes it look like a reflow gone horribly wrong. So it's going to have to come off. I am curious why they thought the south bridge was the problem. Okay. Before we do, let's just let me get set up. We'll do a few checks, see if we can find any shorts, you know, around the south bridge. Of course, there may be merged balls under there right now, but we'll look around to see if we can find some shorts. All right, let's take a quick look around the board here. See if we're reading any shorts. I'm just going to go to continuity mode. Our 5-volt rail. Nope, not shorted. I'm sure 12 volts is not shorted. Is this fuse good? Feeding 5 volts? Yes, into this standby supply. Power here. Any shorts? Here's a 3.3 rail. No, 1. Oh, okay. No, that's ground. I always do that for some reason. 1.15 is not shorted. I'm just tapping some of these capacitors around this. Okay, that is a short there. And if memory serves, that does connect to the south bridge. There's a tiny capacitor here. Let me see if I can get the microscope cranked up. And I'll show you exactly where I'm probing. I know that's helpful to some people. Okay. Right. Get it in focus. So this is an RT5126. And I'm in continuity mode still. Light probe on ground. Right here, this small capacitor right here is where I was checking. And a rather dead short, 1 ohm short to ground. Sometimes I like to check over here, but I don't think any of these others will be shorted. Doesn't look like it. Just that one. But I think that does end up underneath the south bridge. Okay. So either the south bridge is bad or the balls are merged underneath it. Either way, the south bridge has to come off. Let's remove it. But at least now I know I need to check for, after I remove it, I need to see if I've got a short under the, still on that rail, on this little capacitor after I remove it. We'll see if it's still there. Oh wow. We've got a little bridging going on there. And we have some pads with no solder on them at all. Like that one, those two right there, these. I mean, not a bit of solder on them. So I was just kind of debating whether to reball this one or put a fresh one on there. But I'm going to guess this is a fresh one. I don't know that, obviously. Several of these pads, no solder. Let me clean this up a little and see if our short's gone on that, over on that rail we were checking. I do want to clear up that some of this bridging, like right there, before we go any further. Yeah, some of these pads are totally dry. And they don't want to take solder. Okay. Let me just go ahead and clean this up. Just a tad. Trying to be gentle, because it doesn't look like whoever worked on it before damaged any of the solder mask, which I do appreciate. Okay. See now. Alright, that's enough for the moment. Let me get this pile of flux over here, maybe. Before I get it all over my hands. Alright, now our short was right over here. Let's see if that's gone. Back in continuity mode. It is gone. Okay. So most likely it's just bridge pads right here. Okay, let me clean this up a little bit more. And let's take a look. Here's that, oh, look at this south bridge. A lot of those pads look like they've never had solder on them. I mean, it may just be, I don't know. Just a lot of them look like they've never had solder on them. So let me try reballing this one and clean up some more of this, extra flux down and going on over here. And we'll put it back down. Oh, I did notice one more thing I wanted to point out while I was looking at the board. Let's go over here to the HDMI encoder IC. Way over here. See anything missing? Yeah, they stole a filter off of it. They stole one of the output filters. Looks like original port, original HDMI encoder IC, but they stole one of the filters. That's quite nice of them there. Quite nice. Okay. Well, let's get on with it. Alright, well, our south bridge has been reinstalled. The balls under it look beautiful. I've cleaned it up. Looking nice. And I think it was all a waste of time. Because if I can show you, if I get back on that same capacitor right over here. 1 ohm short to ground. So, yeah, that south bridge is bad. So that's great. I do have some. I was just kind of hoping, you know, they're not cheap. I was hoping to be able to reuse that one. But, yeah, that's not going to happen. Oh, I did notice something else. If I can show you this area right here behind the Ethernet port. If I can get it to zoom in. See where those resistors should be. Those are 75 ohm resistors that have been destroyed, along with the capacitor that normally lives right in there. Yeah. So, lightning damage is what that is. That is definitely lightning damage. So, yeah, that's what we're dealing with. This is a lightning damaged PS5. Well, let me see if I can dig out another south bridge. We'll get it put on there and see if it has any signs of life then. Well, our south bridge has been replaced with hopefully a good one that's fresh off the boat from China. Just got those in. I did manage to knock off a 33 ohm resistor right here, but I've replaced it. Cleaned up a little. Okay, let's see if we have improved things in any way. Couldn't get much worse. Okay, polarity is correct. Let's give her 12 volts and see what she does. Absolutely nothing. No. Let me check under this south bridge, see if I left any alcohol under there. Yeah, maybe a little. Maybe a little alcohol under there. I was cleaning while I had replaced that 33 ohm resistor. Alright, now what does she do? That's better. 300 milliamps, come back down. Perfect, perfect. Alright, I think this will try to turn on now. It'll try. I still need to go ahead and replace this missing HDMI output filter right here. If I can get that, how much you focus? Yeah, that missing filter there. And while I'm in here, I need to go ahead and replace these missing components behind the Ethernet port. And we may have trouble there, because if I'm not mistaken, that connects to the APU. So we'll need to test our Ethernet port and see if it still works. But these are 475 ohm resistors, and I think this is like a 1000 picofarad. I can't remember the value of this capacitor, but it's a large high voltage. I think it's rated at 1000 volts or something. It's not very much capacitance, but it's rated for high voltage. So I'll pull those from a donor and get those installed. We'll take the whole mess out to the garage, and let's just see if she'll try to turn on. Well, yeah, with my loaner power supply, because the power supply is dead also, remember? Yep. Well, I went ahead and I replaced those resistors behind the Ethernet port that were gone, and the capacitor, and I replaced this output filter right here, tiny little thing. And I did decide to go ahead and do some diode checks looking at that port, and I think we have a problem here. If I can show you, I've got my breakout board plugged in. 1.2. on pin 1. Pin 2 is ground. Pin 3, 1.2. That should be about 0.8 of a volt. With my meter, it usually shows 0.8. That looks normal. Pin 4 looks normal. 5 is ground. 6, that looks normal. 7, that's not normal. 8's ground. 9, not normal. 10, 11, 12. These 1.2 should be 0.8. 13, 14, nothing on 14. 15 is good. 16, 17 is ground. 18, and 19. All look good, but these the outputs of this chip, I think when the lightning strike occurred, it got popped too. So yeah, I'm gonna go ahead and I don't know if I have any new of these chips. I don't know. I think I've used them all. I know I have some good donors though, so we're gonna have to get that changed out before I even bother trying to turn it on out there in the garage. So let's get to it. Well, our HDMI encoder I see has been replaced. I did have a new part to put in there. So let's see if this one reads any better. I bet it does. Okay, get a good ground. There's pin 1, excellent. 2 is ground. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, no connection. 15, 16, 17 is ground. 18, 19. Beautiful, beautiful. Now we're ready to try this. We are back out in the garage. I think we're ready to test this EDM010 board. Yeah, I think everything that's needed is connected at the moment. Okay, let's see what she does. Blue light. She's on. No picture yet. Oh, I spoke too soon. And it went away. We're still on. But the picture went away. Still blue. Oh. There we go. Now we're all right. So we have video. That's good. We have power. We have video. We are repairing storage. Wow. I was concerned about the APU on this thing because of that lightning strike. It may not be out of the woods yet. We need to see if it'll connect to the hardline wired Ethernet. That could be the challenge. But we're staying on anyway. We've done our storage repair. Come on. Alright, where's my controller? Where's my controller? Alright, let me find a controller and we'll get on into this thing and see what's working and what's not. Well, I can confirm the Blu-ray drive does work. It actually had a disc in it. Mortal Kombat 11 for the PS4. And yeah, so that's good. That works. Okay. Now I need to fix that dead power supply. All right, let's get it inside. We need to make it work. All right, so we need to fix this power supply. Let's see if we can knock this out relatively quickly. And again, I must say, do not open up your power supplies because there are dangerous voltages inside that can hurt you or kill you. So, yeah, I don't believe this one's ever been opened. Maybe this is the supply that was in with that console. It could have been. I mean, how would you know? So it's possible. It's possible those screws are missing out of the back because they tried another supply. That would make a lot of sense. They tried another supply, and that didn't fix it because the supply was dead and the power supply was dead. I did plug this in when I got in here just a moment ago, by the way, just to double check to see if it was, you know, not working, and it's not. Also, the output terminals do not appear to be shorted. You know, that happens sometimes, but not this time. So it's not, most likely not an output failure. Make more sense, wouldn't it, to be an input failure, since we know this thing was hit by lightning. Well, assuming this is the supply that was in it. If it was hit by lightning. Okay, and I have had it plugged in recently, so I am going to be very careful. And I am going to discharge these large filter caps. These right here. We will discharge those carefully, not with a screwdriver. Positive and negative. Nothing. Okay, well, in that case, I'm going to say our fuse is blown. If there's nothing there, and I just had it plugged in, I'm going to take a wild guess that our fuse is blown, but the fuse never blows. Not really, it doesn't. It just, everything else blows. Okay, continuity mode. Fuse? Nope, fuse is still good. Well, darn. Fuse is good. How about, let me get to this little fusible resistor in here. It's still good. Wow. MOSFETs? Do not appear to be shorted. The output is not shorted. Well, then what's wrong? This thing should be working. Yeah, fuse, definitely good. Did we just lose our DAP-053? Because that DAP-053 right here, you know, it does sense the AC voltage. You know what I'm saying? There's resistors between there, but still it has a indirect connection to the AC line. It's sensing it. Sensing for overvoltage or whatever all it senses for. So if there is a spike on the line, it can come all the way into this and do some damage. Speaking of which, let's look at that DAP-53. I don't have my notes in front of me. We'll do a quick check on some of these pins of the DAP-53. Starting with pin 1, which is right here, I believe. 2. Oh, that looks low. 0.09. That looks pretty low. Pin 3. 4 is ground, I believe. 5. 6. Yeah. 7, I think, is probably no connection. Well, that looks 8 looks normal. This one 9 should also be like 1.15. Yep. 10. 11. 12. 13, 14. I missed something because I missed one somewhere. That's 16 right there. 15, 14, 13. Yeah, 12 is no connection. 11, 10, and 9. So the only one that really stood out there was number 2. Yeah, that seems really low, 0.09. I don't know what that connects to. I have to look real close and see if we can figure it out. But pin 2, of course, it could just be the chip itself, but that's pin 3. That looks really low, 0.09. Let me see if I can find my notes. But I'm rather sure that is bad low. Not a dead short, but not far from it. We are looking under the microscope in the area of the DAP53, pin 2. And pin 2, yeah, according to my notes, should be like 0.571, and it's 0.09. Now, I've had that before, and the chip could be damaged. There's also a Zener diode right here that's connected directly to pin 2. That's an 8.2 volt Zener diode. You can see it's marked there. You can read the markings, ZD or ZD. So 8.2 volt Zener, that could be the issue. There's also a connection, I seem to remember, down to Q34 right here, this MOSFET. So it may have gotten that, may have gotten both of them, may have gotten all three, the MOSFET, the Zener, and the IC. Let's remove the Zener, and we'll see if that short goes away. Seems like the quickest option. Add a little leaded solder to that. See what we get. Turn this heat down a little bit, maybe 375. All right. Of course, there's glue underneath these chips that holds them down. What do we have now at that location? We're still 0.08. So we're still shorted. Zener may still be good then. I'm going to go ahead and remove this DAP53. And then we'll do a check while it's off. And if we still get a short then, it pretty much has to be that MOSFET. I'm just going to add a little leaded solder just to kind of lower that melting temperature a little, because this would be lead-free solder. Alright, and I'll try to heat this up and get underneath it because it is glued down. There we are. Get that out of the way. No bridged pins. Okay. Let me check now on pin 2. 0.52. That is more like it. 0.52, 0.53 in diode mode. Okay. What about our Zener here? You know, I think I may just replace that Zener. Anyway, if the chip took that good of a hit, you know, I have about 100 of these. I have like 90 left at this point. Alright, well, our DA53 has been replaced. We're ready to test this. I've got my load connected. I'm set for 10 amps over there, constant current. I think I will bring this voltage down and bring it up slowly. Let's see what happens. Okay. Yep, she's starting to try to work. There's 120 volts AC in. We're only getting 8.7 out. So close, not quite right though. Okay, so we're working, but we are low voltage. Okay. Low voltage. Seems like I've seen that before. And I want to say I need to discharge some capacitors. There's some small MOSFETs on the other side of the board that I want to say have caused that issue before. So let's look into those. Alright, I removed Q34 right here and tested, no change. I know I had trouble with this one before, causing a problem, like a shutdown type problem. But that didn't do anything, so that's out right now. So I went ahead and I lifted one pin of this opto isolator, pin 2, because this is some type of a shutdown signal from the hot side to the cold side. So I lifted it to disable it, and I broke the pin off, I think. So I'll probably end up replacing this opto isolator, but let's just see if this does any good, because I think I've seen this low voltage type thing where there was some kind of a weird feedback or shutdown signal going on. So I've got my load connected, power is in. Let me just turn it on. And there we go, 11.9 volts at 10 amps. Okay, so that's what it's going to be. Something else that lightning popped other than the DAP53. I still don't know actually. Turn that off. It could be the D8. Well, I got to replace the opto isolator anyway. I know I broke it. Broke that pin off when I was trying to pry it loose from the board right in there, if you can see it, that pin. I think I'll go ahead and replace this chip right here. This is a, I can't remember if this is a MOSFET or if it's a Q32. I can't remember which one that is, but I know I have them. I'll go ahead and replace it in case it's broken down. I'll replace that and the opto oscillator, and I think we'll be good to go. Well, I just want to give you a close-up view of what I have replaced here. I replaced IC51, this soft 2 isolator, mostly because I broke the leg off when I was trying to pry it up to isolate it. I snapped the leg off. I replaced this transistor here, which is a MOSFET. I think this may have been the actual problem. So I replaced that Q32. You can see it, Q32. And I replaced Q34, which is another MOSFET, because I removed it during testing and I lost it. It's lost somewhere on the bench. So, but I have some of those, so I replaced that. That, along with our replacing our DEP53, which I need to clean some flux out from under there. And that's all I did. So let me get it put all back together. I'll clean it up some more, and we'll test it. Well, this PS5 is fully reassembled with our repaired power supply. Let's see, we replaced the south bridge, the HDMI encoder, and several resistors and a capacitor. I think that was it. So yeah, lightning took a toll on this one, but we're very fortunate it is back among the living. Well, I hope you liked that one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up, and I will see you in that very next repair. So long for now.